Okay, this is probably going to be the final lesson concerning anything about the packet. This is on page 15. So this is how do you write like a quartic function. I think the problems before this were with a cubic function. What you have to do is look at your roots. So here we have a root where at -3, at 0, at 2, and at 4. So we need to turn these into factors. So I have x plus 3, x is 0, so just x, and then x minus 2 and x minus 4. What I'm going to have to do is FOIL, distribute this. So let's do this group first. And I get x times x is x squared, x times 3 is 3x. So now I have a new term. And then here, let's FOIL this out. And I get x squared minus 2x minus 4x plus 8. Which will give me x squared minus 6x plus 8 times x squared plus 3x. So I'm going to show you how you need to do that over here. Okay, I'm going to rewrite that. X squared plus 3x times x squared minus 6x plus 8. So, what you do is distribute the x squared here, and here, and here. And then you will distribute the 3x here, and here, and here. So, x squared times x squared gives me x to the 4th. X squared times negative 6x gives me negative 6x cubed. X squared times 8 gives me plus 8x squared. Now we'll do the blue here. 3x times x squared is 3x cubed. And I'll line these up together so that we can just add them at the end. 3x times negative 6x gives me a negative 18 leading coefficient. X times x is x squared. And then 3x times 8 gives me plus 24x. And I'm going to add these together. And I get x to the 4th, negative 6, positive 3 gives me negative 3x cubed. Negative 18x squared plus 8x squared gives me negative 10x squared plus 24x. Okay, what I want you to realize is this graph right here, that's the function, the graphic representation. Here's the function when it's in standard form. But this function is made up of many different things. It's made up of 4 linear functions. X plus 3, x, because that's really like x equals 0 or x plus 0. So x plus 3, x, x minus 2, and x minus 4. It could also be made up of 2 quadratics. This goes on to another page in our packet that I want us to reference as well. But I do want you to see that functions are made up in many different ways. Let's see what else we can look at in the package. We did those. Right here goes along with what I was just talking about. We could take, because these three terms go with this graph, these two terms go with this graph, and y'all, when you do this one, you're gonna have to flip it over because this is upside down. I'm sorry, when I taped it in, I didn't even realize it. All right, this one has 4 linear terms. Here's the graphs of those linear terms: x minus 2, 4 minus x, and 3x minus 6. When we multiply those out, and that's what it wants you to do, is determine the product of the functions algebraically. And then you are going to sketch your new graph. So you're going to multiply these together just like we did that quartic that we just did. And you're going to get a new equation. And when you get that new equation, you are going to see that it's going to have zeros right here and right here. How many zeros will it have here? This line intersects this line, so they both cross the x-axis right here. So we will have 2 zeros at 2, 1 0 at 4. So I would suspect when you graph this, I know it's going to be a positive leading coefficient. So it's going to start down here because it's a 3rd degree, and it's going to end up here. And I'm going to have roots I'm going to have a root here. And how many roots am I going to have at 2? I'm going to have 2 of them. So somehow or another, this function, is going to cross. I don't know what it's going to look like, but it's going to bounce there, because remember, when there are 2 roots, it bounces, and it's going to turn and it's going to go back up. That's what my cubic function is going to look like. Now, is it going to look like that exactly? Probably not. But the characteristics are going to be the same. Starting here, ending here, bouncing where I have 2 roots, crossing where I have 1. You need to, oh, by the way, page 13, mark that out, because this is really like your page 7. So you can just put a big X. You've already done this if you've done page 7. Please, please, please pay attention to how to do this. You will see this again. Domain, range, relative, max and min, in behavior, increasing and decreasing intervals. If I have time in this lesson, we'll come back and do this, so you can get a little more practice. We've done multiplicity. There's more distributing. That's what we just did the first. Let me look at that. Okay, let's give a look at this. Which function has an odd degree? So this says a polynomial function r of x that has only imaginary zeros. And then here we have x squared times negative x. So we've got 2 roots there, 1 root there, 3 here, and 1 here. When we add these together, 2, 3, 4, 5, 6, 7. That, for sure, is an odd degree. What about this one? If it only has imaginary zeros, no real zeros, so whatever the function is, it's occurring away from the x-axis. And if there is one imaginary, there has to be 2. They are always only in a pair. So there's no way that could ever be anything but an even degree function. Let's look at these. Number 43. Which function has a degree divisible by 2? This polynomial has an absolute maximum. So it must be an even degree. Because if it were an odd degree, it would not. That has no maximum or no minimum. Oh, I drew this one wrong. Sorry about that. I drew it as a minimum, not a maximum. There we go. Still an even degree. So this for sure is even. What do you do with this one? What's happening here? 0, 0, -1, +1. So let's see what that looks like. 0, 0, -1, positive, -2, positive. 1, negative, 2, negative. What's happening? It's going in this direction, going in that direction. So that one is odd. Now let's look at 44. Which function has the greater output as x approaches infinity? An odd degree function with an a greater than 1. So that means it's positive. It's going here and ending here. So it's doing something like that. So this is saying as x approaches infinity, what is my f of x, or what are my y's doing? That's also approaching infinity. Let's look at this one. That's a negative, is that a 6th degree? So it's going to be doing something here. 1, 2, 3, 4, 5. Which has a greater output as x is approaching infinity? As x approaches infinity, f of x is approaching negative infinity. So that's how you interpret those type problems. Let's look at these and see, can we graph them? These are going to be our last two because it's about time for my next class to start. Okay, so degree 5 starts in quadrant 2. Great. If it starts down here, it's going to end up here. Huh. Is that even possible that it's going to end in quadrant 4? No, because the reasoning being, if it's an odd function, it ends in one direction, starts in one, ends in the other. With these, they would both be ending in the same direction. Okay, let's look at this one. Even degree. It increases to x equals -2. Then it decreases to x equals 0. Then it increases here. And then it decreases. Has a relative minimum where y is equal to 1? Or is that negative 1? Looks like, okay, 2 absolute max at where y is 4. So somewhere up here is going to be my max. And if I'm reading that right, let me get my packet and see if I can read it better from here. No, y equals 1. Okay. So it's going to have a relative min here. Sorry about that, the way that looks, but okay, even degree. If it's going to have a minimum, that means it's going to be going up in both directions, I believe. Okay, it's oh no, absolute max. Sorry. So it's going to be ending here and here. Okay. So it has absolute maximums up here. It increases from here to -2. So would we go up here? And then it decreases to 0. But my relative min is here. And then it says it increases to where x is 2. And then it decreases. Yep, we can draw that. Don't be fooled by this right here. That's how I drew these dotted lines in, so that we could see where my max and my mins are. And then it's telling me where it's increasing. And remember, it starts to decrease wherever there is a turning point. Okay? All right, that's going to be it for finishing up the packet. If you have any questions on anything, please reach out to me. Maybe I'll have time to do just another one on graphing these, because I want to make sure that you know how to do these type problems. Thanks, y'all have a good day.